So in this video we're going to have a look at the 2019 paper. We're looking at 2019 section B question 6, which is the design for rugby trophy question here, so an ellipse and parabola question. So just to read through the question first of all, the figure shows a design for a rugby trophy. The curve ABC, so our curve ABC here, is a parabola with vertex at B, okay? So vertex at B, so that's important to know where your vertex is first of all. The curve DEF, so the curve DEF here is identical to a portion of the same parabola with vertex at E, okay? So basically that's the same portion of this parabola here, so it's the exact same size of a parabola. So we just have to construct this one first, and using transformation geometry, using a translation, we'll just move that one down to there and we'll create our second parabola there, okay? Then in the second part of the question you're told the curve JKLM, so the curve JKLM is an ellipse with focal points N and P, so our focal points N and P there. So you're given that much information there. You can see you're given the length of the major axis there, you're given your focal points, and you'll notice there obviously we're not given the length of the minor axis. The line BT is a tangent to a point, or is a tangent to the ellipse at a point T. So the line BT is a tangent to the ellipse at the point T. Now what you'll notice there as well, we're not given the exact dimensions for point T, but we are given B, so we'll have to construct that tangent from a point outside the curve, okay? So you're asked to draw the given design, showing clearly all constructions and points of contact, okay? So we're going to start down here with the parabolas here first of all. Now, it's quite a tall drawing here, so start reasonably low on your page. I have set up some of this here already on the page here, so I've just drawn in the rectangle here for the parabola. I just came up 40 millimeters on the page to the bottom of the rectangle there, just to make sure you're not going to run out of room. But that's something you need to consider in the exam as well, that you're not going to run out of room. Now I'm doing this on an A3 sheet here, you'll be doing it on an A2 in the exam, so it will be less important, we'd say, in the exam, or there's less of a chance, should I say, of you running out of room on an A2 sheet. Okay, so you can see here from the question here, we can see that our rectangle containing the parabola ABC is going to be 40 millimeters in height, and it's going to be 160 millimeters in length long. So that's what I've constructed here. We have the rectangle here, okay? Now, I know the vertex of the parabola here is going to be right here, so this is going to be point B right there of the parabola, and that is the vertex there, okay? Over here we'll have point A, and over here obviously will be point C, okay? So there will be our 3 points of our parabola. So I'm just going to divide up one side, and I'm going to use axial symmetry then to bring it across the other side then, okay? So using our construction for division of lines method, we're just going to draw a line out here from the vertex here, any length, any angle there, okay? So I'll just draw this a little bit heavier so you can actually see it on the video there, okay? So what we're going to do is we're going to mark out 4 divisions on this here, 4 equal divisions on this line there. Okay, and then obviously using our sliding set squares, then we're going to join that back to the outside corner here. Okay, and that will give us our 4 different divisions of that side there. We're going to do the very same thing we're going to have to divide up this side into 4 equal spaces again. You should be very familiar with this construction at this stage. Again, we're going to go for 4 different divisions, so you have to divide this side into the same amount of divisions as you've divided the top of the rectangle into. So again, using our sliding set squares then, we are going to join from that point there back to corner then. Okay, so if we're just going to it's a good idea. It can help you just to number these here. So what we're going to do here is we're going to number these. So our vertex is 0, so we're going to go 1, 2, 3, 4. Okay, and then down the side, then we're going to go 1, 2, 3, 4. Okay, and when we do that, then it makes things a little bit easier when it comes to joining up our points, that you won't make a mistake. So I'll just do one of these in colour here so you can see it, and we'll do the rest ordinarily. So I'm going to join point 1 to B. Okay, and then we're going to go vertically down from point 1 to meet it. Okay, and at that point there, then that is a point on the curve of the ellipse. Okay, so join to point 1 and draw down. Okay, so we can continue on. I'll do the rest of them in colour here as well, just so you can see them there as well. So 2, and then vertically down from 2, that gives us our second point there. Okay, right there. And likewise 3, and vertically down from 3, and that gives us our point there as well. Okay, now our last point there will be point 4 in the corner. So if we were to join down and bring down, that would end up as point 4 anyway. Now, before we actually draw in the curve, it's easier to bring them across before you draw the curve. So just using an axial symmetry here, we're going to bring these points across our centre line. Okay, and there's our point on the other side then. Okay, so from here then you can use your flexicurve to draw in this if you like, or if you're capable and you're practiced at, you can use a freehand method as well. Okay, so to do it freehand, you just need to ghost over it. Again, I'm using my H pencil here just to ghost over it. Make sure you're curving between your points. Try not to scratch too much on the page, as in try not to go back over too many times on the page, and just work your way around. Take your time now. Again, neatness is very important. The quality of the curve is very important. So just curve between your points. If you do it lightly first, if you do make a mistake, then you can always rub it out and it won't be seen. Okay, but just make sure to curve between your points. Watch where you're going, look to the next point as you move along, and once you get it drawn in lightly, you can then, in as one smooth action if you can, try and go over the points as neatly as you can. Okay, so that is our parabola there. Okay, so that's our first ABC parabola. Now, if we look to the question, you're told that in the question, the parabola DEF is the same, a portion of the same parabola. So you can see here, B is down, or point E is down 20 millimeters from point B. So we're just going to use a translation to bring these points down. We're not going to start doing the construction for the parabola again. Okay, so if we just bring, we already have the points from B down. Okay, so we're going to bring down the remaining points here for the rest of the parabola. So just straight down. So each one of these points is going to move down 20 millimeters. So we can do this with our compass then. So for any translation, we need a distance and a direction. So our direction is vertically down and our distance is 20 millimeters. probably won't need to go, we probably won't actually need to use these 2 points down here, but it's no harm to have them done anyway, okay, because we will be stopping when we come to here, okay. So once again, there's our points for our parabola as we go around there. So all you need to do is, again, draw that in. So get your H pencil, just like you did before, ghost it in first, okay, and obviously we won't go past there or there when we're going over permanently. So if I start here now again, again being careful to curve between the points. Okay, and that's our parabola done. We can just join up the base parts there and there. Okay, so that is the part of the parabola there. So that's D, E, and F there. So this is point D, this is point E, and this is point F here. Okay, so that's the first part of the question done there. Okay, so moving on from that then, we're going to come up here and we're going to create our ellipse here, okay? So we're going to try and create our ellipse here, okay? So the first thing you need to do here, from point B, you're going at 60 degrees out this way to a height then of 30 millimeters, you get point J, and then you're going back at an angle of 60 degrees here again, okay? So the light here has just shone in here, so it's not just ideal for this. Okay, we're going to work on anyway. Okay, I hope you can see this okay with the light here. It's just the sun is shining in. Okay, so I've already set this up anyway, but I'll just go over so you can see it there. We're going to go back here at an angle of 60 degrees to there, and then we're going to go back in, so that gives us to a height of 30 millimeters up. So I would have come up 30 millimeters here, and I would have found this point going across here, and that would have given me point J there. Okay, so that's point J. So from point J then, we're going to go back up at 60 degrees to a distance of 170. Okay, so to a distance of 170, and then we'll mark that off there, 170, and it's 85 millimeters up to the center of the parabola. So the center of the parabola, so the minor axis will be at 90 degrees to the major, which means if this is going at 60, this one will be going at 30, and we have the major and the minor axis, the positions of them set up there. Now, we also need to set up our focal points, points N and P. So we're told that they are 70 millimeters from the center of the from the center of the ellipse. There are 2 focal points there. Okay, so we have our focal points there of N and P. Okay. So now we know the length of the major axis and we know the positions of our focal points. Now, if we come back here to what we've been doing several times before, okay, if you're given major, minor, focal or points, okay, so they are the parts of an ellipse. So you could have the major axis, the minor axis, you could have your focal points, you could have your a point on the curve. If you have any 2 of these, you can draw the ellipse. So if you have the major and the minor, you can draw the ellipse. If you have the major and the focal, one of your focal points, you can draw the ellipse. If you have the major and a point on the curve, you can draw the ellipse, okay? Same as if you have a minor and the point on the curve, you can draw the ellipse. So any 2 of these here, you need to draw an ellipse, okay? So what we're going to have a look at here, what do we have here? We have the major axis and we have our focal points, okay? So these 2 here. So again, this is a very straightforward one. you should all know this by now. Half the major axis swung from one of the focal points will give you the minor axis. So we're going to take half the major there like that. We're going to take that, bring it to one of our focal points here, strike an arc where that has crossed through my minor axis there. From there to there now is the radius of the minor circle. So I can take this here, take my compass, set it to that point there, and I can draw in my minor circle. I can also, when I'm this far here, I can draw in the major circle. Okay, so I have my major and my minor circle drawn in there. Okay, so as I said, just to recap on that, half the major, so measuring out half the major with my compass there, swung from one of the focal points there, will give me the minor, the position of the minor circle. Okay, so that's that much there. From here then, we're just going to have to divide up our ellipse with our 60-30 set square. Now, this can put some people off because the fact that the ellipse is at 60 degrees. For some reason, this can throw students a lot when it comes to dividing it up. If it is at 60 degrees, you can still divide it up in the exact same manner. Okay, so we're going to come along here with our 60-30 and we're going to divide it up. So we have the 30 there already. We need to bring our horizontal line here. And that is our circle divided up. Okay? Now, at this point, it's important to pick out the end points of your major and your minor circles. Okay? So pick out your 4 points found already on your ellipse. Okay? So we have a point here and a point here. So that's the ends of our minor. And we have a point here and we have a point here. That's the end of the major. Okay? So sometimes it can be no harm to write in as well if it helps you. So this is our minor. Okay, and this is our major. Okay, so that's our minor and our major axis. Okay, now this is where confusion can start too, as well, with dividing this up and now finding our points here. Okay, so we have our point here. We're going to work around here clockwise to find the rest of our points here on our major and our minor. Okay, so first thing we need to look at here, where the line crosses the minor circle, you go away from the minor axis. So cross the minor away from the minor axis there. Okay, so I'll actually just do this in colour here so we can see it. Okay, so away. Where the same line crosses the major circle, you go towards the major axis. Okay, so away from the minor, and we go towards the major there like that. Okay, and that will give us a point on the curve. Okay, so if you remember that you go away from the minor and go towards the major, every time you do this, no matter what orientation the ellipse is in, whether it's vertical, horizontal at 60 or whatever angle is 45 or whatever angle it's at, you will always be correct in what you're doing. So if you want to think of it, we just write this out here. It's important to write these things down and to draw these out as you're doing it. It'll help you to remember it. Okay, so to construct the ellipse, what we're saying is so we go away from the minor, and go towards the major. Okay, so you go away from the minor and you go towards the major. If you want to think of a way to remember that for yourselves, okay, as you get older, you could be playing minor football. As you get older, you will be moving away from being a minor. Okay, so a minor is considered a younger person, so you will be considered to be going away from a minor and you'll be going towards an older person, and we'll consider an older person to be a major, okay? So as you get older, you go away from being a minor and you go towards being a major, okay? If you want a little thing like that might help you actually remember it, okay? So that's the way we do it. So I'm going to continue around like that there. So while I'm here, I'm going to do a little bit, it'll speed you up if you do two of these, the two top ones here together, okay? So that's my second point there, and again, same for these two here. So it can just speed you up a little bit if you actually do two together, but obviously you only do this when you're actually comfortable that you know exactly what you're doing and where you're going, okay? If you want to just do one at a time, that's fine as well, but this is just about saving yourself a little bit of time in the exam when you're doing these. If you can position yourself that you kind of do two together here like this, it just saves that little bit of time in the exam. Okay, so there's my points set up there. I'll just zoom in here so you can just see them a little bit better. I hope the lighting is okay here. Okay, so once you have that much done there, you can, obviously, you can use your flexi-curve if you like, okay? Some people are good with this. If you want to practice freehand as well, you can, although if you're not neat with your freehand, and it's not right, you really should use the flexi curve. So you can do it either way, but there is marks going for the curve, so just be nice and careful, take your time with it. Also there's marks going for neatness and presentation, which is a huge thing. So in the likes of this question here, there will be 10 marks for neatness and presentation, so 10 marks is a huge amount of marks out of 70 in total. So just again, I'm just ghosting this in nice and lightly, again being careful to curve between my points. And the good thing about just going along nice and carefully is I can always come back and rub it out if it doesn't just look right, or if I do make a slip or make a mistake. So again, curve between the points as much as you can. Once I'm fairly happy with that, then I'm just going to come along now and just try and go over as neatly as I can. Okay, and that is my ellipse there then. Okay, so if I just zoom out there a little bit, okay, we can see there we have our ellipse set up there. Okay, so we have a lot of the question done now at this stage. A lot of the marks go for just the ellipse and the parabola itself. So at this stage, a lot of the marks are accounted for. Now, of course, we have the tangent and so on here, but the main parts to get done in these questions, if you were actually running out of time, would be to get the ellipse and the parabola drawn. If it was a thing, it was the last question in the exam and you really were running out of time, make sure you try and at least get the get the ellipse and the parabola drawn itself. Okay. So from there then, I can actually just draw in this line from B up to J, because that's just at 60 degrees there, and there is it's not actually a tangent. So, okay, so that's my line B up to J. Now, I have my focal points there. The next thing I'm going to look at now, the next most important part of this question, is the tangent from B to T. So if we look back on the question here, okay, we're looking here, we have a tangent here from point B to T. You're not given where T is, so we're going to have to use our construction. Okay, we're going to have to use our construction for this, and it's a construction which is probably the one that's hardest to remember from a point outside the curve. Okay, so again, you're going to have to show your workings for this. Okay, so what we're going to have to do here is, from our point, you extend to the closest focal point there. Okay, so from our point outside the curve, extend to the closest focal point there. Okay, and what we're going to do is we're going to draw an arc through that point there like that. Okay, so you can see there, I'll just zoom in here a little bit more so you can actually just try and pick up exactly what I'm doing here. From point B, we're going to extend to our closest focal point, and we're going to draw an arc out there like that. I'm drawing this a little bit heavier here so you can just actually see it. Okay, so there's our arc there. That's step one. Okay, step two then, okay, we're going to take the full length of our minor circle. Okay, so this will be the full extension of your compass. So full extension of the compass on this type of compass anyway. Okay, and we're going to take that and we're going to position that the full length. So I've just taken the full length of the minor or the major axis, and I'm going to bring that to the furthest focal point away, and I'm going to strike an arc to cross back through my first arc like that there. So see that point there, and that gives us this point right there. Okay, that gives us that point right there. So once I've just to recap there, I put center of the compass on B, extended to the closest focal point, drew an arc, took the full length of the major axis with my compass, and I've drawn an arc from my furthest away focal point through there. Where the two arcs cross each other gives me a point there. Okay. What I'm now going to do is I'm going to join that point back to the furthest focal point away. Like that. Okay. And where that crosses my curve is the point of contact. So right there now is my point of contact. And you should always mark it as POC, because you asked the question to show clearly all construction and points of contact. That is now my point of contact. All I have to do now is put my set square at B, move to the point of contact there, and that is my tangent drawn in there. So that is point T. Okay, that is point T. So look, it's relatively straightforward once you know the procedure for doing it. So just recap again. Center the compass on B, extend to the closest focal point, draw a circle, or draw an arc, I should say. Once you have that done, then take the full length of the major axis, and swing another arc from point P. Where the two arcs cross each other will give you a point. You join that point back to the furthest focal point away there, and that gives you where it crosses through the curve gives you the point of contact there. Okay, so at this stage now we have the most of the drawing done. Okay, there's a few bits to be put in then, okay, in the likes of this part here and this circle here. Okay, so the circle just goes from there to there, it doesn't extend around, and then this part here should be relatively straightforward. I'll just quickly go over it here and actually do it there. So this circle down below is radius 20. Now it only starts from there and it goes to there, and likewise here it starts here and it goes to there. Okay, so that is the radius 20 there. Okay, so in your drawing it's actually shaded in there. Now the next thing then is for this point here, we have our points joined back to it here. So each side of the centre of the ellipse, we go 15 millimeters each side of the centre of the ellipse, and we join them points back to point in, or back to your focal points, I should say. There. Okay, and then what you need to do is actually draw in your lines, your vertical lines going along here like that there then as well. Okay, so each one of the lines then is 15 millimeters spaced apart. So you have 2 lines each side that's 15 millimeters apart. Like so. Okay, so that is the main part of that there then. Okay, so you have that drawn in, you have all your points there. This part down here, if you just to make it look like the actual drawing itself, is just shaded in here. Now obviously if this isn't critical, or there isn't actually marks going for the shading of it, there is marks going for neatness and presentation. Make sure that you have all your constructions clearly shown, and that you're not actually rubbing out your construction, or you're not shading over your constructions, that you're covering them up or anything like that there. Okay, so that is the solution to it there then. Okay, and that is about the time within the exam, so that's about 32 minutes there, guys. Okay, really you have about 35 minutes in the exam for your long questions, so that's the time it should be taking you there as well. You should be looking at your neatness and watching your neatness there. Make sure you're marking your points of contact, and you can see there you have lots of time. 35 minutes is loads of time to do a question like that, and it's not the most straightforward of ellipse questions. It is at an angle there, so you have time to do it in the exam if you just steady yourself and take the time to do it. Remember this part here, it's very important. Okay, if you have any two of them, to draw it and go away from the minor and go towards the major. So as you get older, you go away from being a minor and you go towards being a major. The construction for the actual tangent to a point outside, from a point outside the curve, look, it's just one of them things you need to learn off the method for doing it. There's no other way around it. Okay, it's just something you need to learn off, and that's it. Okay, so I hope that was helpful, and I hope that you have no great difficulty with that question now.